Okay, so let's see. All right, so section 3.6 is where they were talking about relations and functions. And so, remember, a relation is a set of ordered pairs, and what's the definition of function? Remember?
It's a special kind of relation.
Okay, but specific, be a little bit more specific. So it is a relation.
For each x, there should only be one y.
Yeah. In which for each x, there has to be one y value. Exactly one y value, right? Exactly. And so we talked about, if you look at the notes from last class, we talked about sometimes doing it as a mapping and seeing if there's only one arrow coming from each x. So as a quick review, I'm just doing one of them. Is this relation a function? So we have 2, -3, 5, 6, 0, -3, 1, 2. Is that a function or not a function? Okay, so you do a little mapping. If you want to draw the mapping, you can.
It's not a function. It has 2 -3s.
Okay. All right, so y'all saying it's not a function?
Yes, sir.
Okay. Anyone disagree? All right, we'll all get it wrong.
Oh, nice.
That's why I was saying if I got it.
Y'all didn't look at those notes yet, right?
No, of course not.
All right, so let's look at the number 2. Remember, the definition of function says for each x, there's got to be only one y.
Oh, not
When x is 2, what is my y?
-3.
For this x, there's only one y. When x is 5, what is my y?
6.
For this x, there's only one y. When x is 0, what is my y?
-3.
For this x, there's only one y.
one Y
What
can
is-
have two X's.
What is, for x equal 1, what is my y?
2.
2. Knows that for each x value, there's only one y value. So this is a function. So what confuses people is they see the y's occurring more than once. It's okay for the y's to occur more than once. The x's can't each have more than one y value. So this is a function. So that's what we talked about last class period. Okay, you have those worksheets that are due. Just go ahead and turn them in.
Okay.
All right. Now let's see. Let's look at this. All right. I think we started talking about domain and range, right? Okay. So in this case, what would be the domain, and how would you write it? How'd you-
2, 3, 0, and
You put it in brace, so right?
Yeah.
You have to write as a set. And if it occurs more than once, you only write it
1.
once. So what's the domain?
2, 3, 0. That's
No,
5.
2, 5.
That's 5.
0, and 1.
Yeah.
And close bracket. And then for the other one, open bracket.
When we say bracket, you mean brace, right?
Brace, yes, sir.
Okay.
-3, 6, and 2. Close brace.
Okay. All right. And again, don't say -3, 6, and 2. Only list it once. All right. And then, all right, let's do this example. So let's say this right here. Let's say I have this point, that point.
2,2.
Yeah, I'm not going to list the coordinates though. let's say I had this, this, and let's say this. Okay? So I had those.
Would you first want to write down all the coordinates to help you out? Or
Okay, so on a worksheet, you may just see it written as a bunch of dots, right? So if you need to, go ahead and write the coordinates out. So what are the coordinates of this one?
3, 0.
3,1,
3, 1.
Oh, it's, okay.
What's this one?
2,
2,
2, 2. Let's do this one right here.
negative 3, negative
hmm And what's this one?
-1, 1, 2, 3, 4, 5.
5. So instead of writing it as a set like I did here, see this?
Mhm.
I just graphed it. Okay? I just graphed it. All right, so what's the domain?
You could still do,
What?
I was gonna say you could draw your little thing, but.
Okay, so we can talk about is this a function or not. Listeners, we can do that. So is this a function?
No.
Why not?
Yeah, yes, it is.
It is. For each x, if you draw your mapping, for each x, there's one y value, right? So that's a function. So when x is -3, what's my y value?
Negative 4,
-4. When x is -1, what's my y value?
5,
When x is 2, what's my y value?
3.
2.
Oh, that's 2.
When x is 3, what's my y value? 1. So for each, put in that box right there. So for each x, there's only what?
1.
One y value. So this is a function, right? You all agree?
Yes.
Okay. Now what's the domain? Now you can go back and read the domain from each of those, or you can use just this right
The
here.
domain, on the domain, they don't have to be in any certain order?
No.
Okay, so negative 3, negative 1, 2, and 3.
Okay. What's the range?
Negative
So remember, the
4,
range is a set of y coordinates.
Yeah, negative 4, 5, 2, and 1.
Any question on that? Okay. All right. Now look at this one.
Right now.
All right, page 2. Let's suppose we had this one. All right, so you have this relation. Now we talked about a graph being a relation. Why is this a relation? Why is that a relation?
It's a set of ordered
It's a set of ordered pairs, right? Isn't this graph, this line made up of ordered pairs?
Yes,
Okay. Now, how many ordered pairs are on this line?
an infinite number.
An infinite number. How many ordered pairs were in these two examples?
There you go, 4.
No, not an it. What does infinite mean, guys?
Unlimited.
Unlimited. You can't count them, right? Okay, so that's what that means.
Well, that's
Like,
only 4.
like the integers, there's an infinite number of integers. There's no way you can count all the integers. There's no way you can count all the whole numbers, all the decimals, and so on. There's an infinite number. What is the opposite of infinite?
Finite.
Finite. You can count. So if this is an infinite set of ordered pairs, then these are a what?
Finite.
Finite set of ordered pairs. So you can count them. How many ordered pairs are here? 4. How many ordered pairs are here?
4.
I guess 4 again. So there are 4 of them. Okay, so you can count those. There's a finite number. And so when there's a finite number, we just use a set like this. Just write as a set. A infinite set of ordered pairs is going to be written a little bit differently. Okay? But the first question I'm going to ask you, though, is this a function? Does this relation represent a function? And I'm not giving you the equation.
We have to say yes,
Why?
because for every y, there's only one x.
That's not, nope, you don't say it like that.
Flipped it, or
For each, what's the definition, people? For each
Each
x, there's
coordinate,
only
one Y.
one Y.
Yeah, I got it.
Okay?
You might just like
For
to-
each x, there's only one y. So if all you're given is a graph like this, it's pretty easy to determine if it's a function or not. So, for example, notice no points are given, right? So just look at this. Let's look at this x coordinate right here. And I'm looking at this point right here. You see this right here?
Mhm.
So for when this coordinate right here is x,
Mhm.
I get this y value. You all agree?
Mhm.
So far, for this x coordinate, there's only one y value, right? So for example, I could have said if this is 3, then this could be what? 4? So when x is 3, what's my y value? 4. And there's only one. If I look at this one, for this x coordinate, is there only one y value?
Yes.
Yes. For this x coordinate, there's only one y value. It's this one right here. That y value that's associated with this, x, y. What about this x coordinate right here? Now look at the point of the graph right here.
Mhm.
Is there only one y value?
Yes.
Yes. So for each of these x coordinates, right here, there's only what?
One Y.
One y value. For each of those x coordinates, there's only one y value. All right, now let's look at, I'm going to come back to this in a little while. What about if I had this?
It is not a function.
Okay, first of all, is that a relation? Is that a relation? You're supposed to have said it in a fourth of a second.
Yes.
Yes, it's a set of ordered pairs. All graphs are a set of ordered pairs. All graphs are relations. Is it a function?
No.
You got to tell me why.
Because you have X's with two Y's.
That's not true right here. I have an x with just one y.
I mean, but somewhere along that line,
You got to be more specific. Where do you think he's? The answer is it's not a function, but you got to tell me
Okay.
why.
you got where it makes the loop back.
Okay.
There is an
All right.
X that has two.
So
different
right
Y
here,
spots.
this, see this x right here?
Mhm.
This point has that x, this point has that x, and this point has that x, right? So y'all agree that all these points right here have that same x coordinate.
Yes.
Yeah.
But that x coordinate has how many y values?
3.
3. So right away, this whole thing is what?
Not
Not a function. So this is not a function since, I'm going to call this x1 right here. Since x1 has how many y values?
3.
Has 3 y values. All you have to do is find one that does not satisfy the definition and you're done. Okay? All right, now what about this one? You got to find one that does not satisfy the definition.
Not a function.
Does a circle represent a function?
No.
No. Because if you look at this x coordinate right here, see this one right here? Here's the point, and here's the other point with that x coordinate. So you'll agree that these 2 points right here, listen to my words, do y'all agree that these 2 points right here have the same x coordinate?
Yes.
Okay. But what do you say about the y coordinates?
There's 2 of them.
There's different.
They're different. In fact, there's a bunch of places where there's an infinite number of places where that occurs, right?
Right.
I just showed one of them. So y'all, this one as well, right?
Correct.
This one as well.
Correct.
Okay? So all these points right here, these 2 points have the same x coordinate, different y values. Same x coordinate, different y values. Okay? So this is not a function. All right, now when the graph is given though, it is a lot easy to determine whether it's a function or not by what we just did, but by using this idea. Okay, so you see right here, see this, remember this one right here? Let's go to this one right here. Remember this right here, this line? We said this was a function, right? Okay, so this point right here, whatever this x value is, it only has how many y values right here that I'm pointing to?
1.
Just 1. Same thing here, right? Okay, so I'm going to just kind of do this, just what I'm doing. I'm going to draw a vertical line through each of these. Okay? Just don't worry about y, just draw a vertical line. Over here, same idea. This x coordinate right here has how many y values?
1,
Just one. This x coordinate right here has how many y values?
3.
Okay, so when I draw these vertical lines, I'm just drawing them,
Ding, 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 ding.
okay? All right, and then I'm coming right here, and again, I'm drawing vertical lines. So when I drew right here, when we said this was a function, when I drew a vertical line all the way across, it intersected the graph how many times each?
Once.
Just once. It intersected the graph just once. So that means is that when I drew this vertical line for this x coordinate, there's only what? One y coordinate. So that means that there's only one y coordinate for each of those x's. Here, now look at this. For each of these x coordinates, there's only what?
1.
One y coordinate, but it fails when I get here. Because when I drew the vertical line, this x coordinate had how many y coordinates?
3.
3. Had 3 y coordinates.
How much last one?
Put on the,
Five.
yeah. And then here, each of those vertical lines that I've drawn here intersects the graph how many times? Twice. If it intersects the graph once everywhere, then it's a what? Function. If there's any place where it intersects it more than once, then it's what?
Not a function.
Not a function. Okay, this is called the vertical line test. The vertical line test. So the vertical line test can be used to determine if a graph represents a function. All right, so vertical line test can be used to determine if a graph represents a function. Okay? So the idea is this. If the graph intersects, I didn't mean the graph, the vertical line. If the vertical line intersects the graph more than once, anywhere, then it's not a function. Then the graph is not a function. I'm going to use the word relation. Then the relation is not a function. Okay? So whenever you're given a graph, use what test?
Vertical line.
Vertical line test to determine if that graph represents a function. But you got to check everywhere. So for example, if I had this again, watch. So I have this horizontal line. Does that horizontal line represent a function or not a function?
Not a function.
Anybody else?
Wait a minute. Yes, it is a function.
It is a function.
It is a function.
So it is a function, and no matter where I draw this vertical line, it intersects it how many times each?
Once.
Just once. Okay, so this is a function. Okay, it's a function. It passes a vertical line test. I'm going to go ahead and put VLT, vertical line test. So it passes a vertical line test. So this right here, when I drew this circle, you would say this is not a function. And if I say why, you would say what?
Does not pass the vertical line.
Okay, it does not pass a vertical line test. It fails a vertical line test. Okay, and the same thing with the others. So this says this is not a function. And again, a reason could be you could stop here, and since you wrote this, it's not a function since x1 has 3 y values. That's fine. Or you could have just said what? Fails the vertical line test. Okay? Any questions on determining whether a graph represents a function or not? It's fairly easy. Now, when we go back over here, I want to show you something. You see, remember this right here? And then remember this graph where we had how many coordinates? How many ordered pairs? Sorry, 4. No matter where I draw this vertical line, it intersects this graph how many times? Once. Now, be a little bit careful. We're talking about the graph. So this was a finite set. So I'm just going to kind of do this for a moment.
But you can still have a finite set where you have an X having 2 Y's.
Yes. All right. So when I drew those 4 points and I drew a vertical line, did that vertical line intersect the graph more than once?
No.
No. At each point, it only intersected once. Whereas, and he's talking about this, what if you had this? So this, it passes the vertical line test. So it's a function. What about this?
Nope.
Okay, I don't understand because it intersects once here, once here, once here. What's the issue?
Crosses on that third X.
Okay, when I draw the vertical line here, just like we were talking about a while ago, these 2 points have the same what? X coordinate. So that X coordinate has how many different Y values?
2.
2. So it fails the vertical line test. So this is not a function since it fails the vertical line test. Okay? All right. So any questions on the vertical line test? Okay, now what we got to do now is talk about domain and range. Now, domain and range is a little bit more difficult with these. Because it's domain and range here. See, the ones we did earlier right here, that was easy because that was a finite set. This right here has a what?
Infinite.
Infinite set. Those are infinite sets. All right, so let's talk about domain and range in that situation. Okay, so I'm going to give you, you got to listen carefully as we go over this. It's not that easy. So I'm going to give you a handout dealing with that